Good morning to one and all. In today's lecture, we'll discuss the frequency hopping spread spectrum. As you know, in previous lecture we discussed the spread spectrum. So let us memorize the spread spectrum first. So spread spectrum modulation technique employs a transmission bandwidth which is several orders of magnitude greater than the minimum required bandwidth of signal carried information. So the advantage of spread spectrum is that many subscribers can simultaneously use the same bandwidth without significant interference in them. The spreading of waveform is controlled by a pseudo-random noise, that is your PN sequence or your pseudo-noise code, which is binary sequence that appears random but can be reproduced in a deterministic manner. Now, there were two types of spread spectrum modulation technique. First one was your direct sequence spread spectrum, and second one is your frequency hopping spread spectrum. So in FHSS, it is based on the jump in carrier frequency at which the data bearing signal is transmitted. So this jump, or we can say change in the carrier frequency, occur according to the corresponding spreading PN sequence. So coming on back to your FHSS, these are my session outlines. Here we will be discussing the block diagram, modulation technique of your FHSS, frequency hopping, difference between your FHSS and FGM, slow hopping and fast hopping, performance, and your applications. So FHSS I have already discussed. It is based on your jump in the carrier frequency at which the data bearing signal is transmitted, and this jump or change in the carrier frequency occur according to the corresponding spreading sequence. Now coming on to the block diagram, we know that FHSS is an example of your analog spread spectrum. Now here we have an original signal that is in a form of your FSK. Why we are not using other modulation technique, I'll discuss it later on. So here we have an original message signal that is in the form of your FSK. Here we have a modulator, or we can say spreader. For it is connected to a frequency synthesizer. Here we have a PN code generator. As we know, okay, for example, if we have a bandwidth that is B, when it is passed through your spreader, we get at the transmitter side that is BSS. So your PN sequence will generate code, and that code will select a carrier frequency. Whatever code we will select, the carrier will get select, and then we'll give it to the modulator. So in frequency hopping, we will be changing some frequency after some instant. So for example, we have a 3-bit code. So that means the total combinations will be 2 to the power 3, that is equals to 8. So here we have represented the code as well as your carrier. Since we have 8 combinations, so it could be in the form of 000, 001, 010, 011, 100, 101, 110 and 111. With respect to that, we have mentioned our carrier frequencies, that is F1, F2, F3, F4, F5, F6, F7 and F8. Now if we select this PN sequence, that is your F4, that is 011. Now see what will be happening. Now this is a frequency hopping. This is a frequency hopping technique. This is the basic diagram of your frequency hopping. So we will be selecting it with the help of a table that we have discussed. Now see, this is your cycle 1 and this is your cycle 2. So this represents your cycle 1 and this represents your cycle 2. We have drawn the graph with respect to the frequency and time. So this is your frequency hopping diagram. Here we will be selecting the carrier frequencies. We will be selecting the frequency and will represent on the graph. Now if I say for first cycle, the first instant it will be selecting the first frequency. So let us say it is selecting your F6. This is your F6. So we'll mark it over here. After that, the second code, if the second code is 001, so it is selecting the second frequency. So it will be selecting over here. Next, for the third instant, if it is selecting the code 010, that is F3. So here F3 will be done. At fourth instant, if it is selecting 000, that is F1. So we'll mark it over here. Now next, if we select the fifth instant, at fifth instant, if it is selecting the frequency, that is 111, having code 111, so we'll mark F8. Similarly, we'll do for the next frequencies. It will mark it over here, F4. So this is how we have represented on the first cycle. Similarly, we will represent it on the second cycle. It will be same only. There will be no changes. The same frequencies will be marked over here. So for first instant, we marked it over here. So I am representing with a black pen. So there should be a difference. After then this, for the next one, we marked it at this code. F8, then F7, 5 and F4. So this is how we will be representing a frequency hopping sequence. Now coming on to the modulation technique in FHSS. As we know, there are different effective digital modulation methods like your PSK, QAM and PAM. But these methods are not effective for your coherent detection. That's why we are using FSK, that is your frequency shift keying. So in FHSS, we use FSK for effective coherent detection because it is less costly than your PSK, QAM and PAM. Now next, we will be discussing the difference between your FHSS and FDM. Now here we can see that here your frequency will not change with respect to time in FDM, while in FHSS your frequency will change with respect to time. Here suppose we have described that channel will change frequency with respect to time. Now suppose if I talk about FDM, we represent F1 as your channel 1, then your F2 is represented as your channel 2, next your F3 will be represented as channel 3 and F4 represented as channel 4. Now if we talk about FHSS, in FHSS, if I have to represent the frequencies, I have to represent, so here it changes with respect to time. For example, if we say for the first frequency, it will come over here, then here, then here, then here. Similarly for second, so what we can see the main difference, in FDM the frequency does not change with respect to time. The channel will not change its frequency with respect to time, while in FHSS the channel is changing its frequency with respect to time. So this is the basic difference between your FHSS and FDM. What is the difference? The difference is the channel will not change its frequency with respect to time in FDM, while in FHSS the channel will change its frequency with respect to time. Now coming on to the next, that is slow hopping and fast hopping in FHSS. Now here for fast hopping, your TC should be lesser than your TB. That means your bit period should be greater than your chip period. That is for fast hopping. For slow hopping, your chip period should be larger than your bit period. So that is known as your slow hopping. So this is the basic difference between your slow hopping and fast hopping. Now, if we talk about the performance of your FHSS system, so it is given by the formula, that is SIR is equals to B upon M minus 1 log base 2 L upon L into RB, where B is your system bandwidth, M is the number of users, L is the number of orthogonal code, and RB represents your bit rate. So this is the performance of your FHS system. Next is the applications. The first application is your Bluetooth. In Bluetooth, for a second, your 625 times the frequency hops in a second only. So that's why Bluetooth is one of the applications of your FHSS. Second one is your JTRS, that is your Joint Tactical Radio System. So this was all about your FHSS, in which we discussed the difference between your FHSS and FDS, basic block diagram of FHSS, slow hopping and fast hopping, performance of FHSS and its application. In the next lecture, we'll discuss about DSSS. Thank you.